All right, so today, guys and gals, we're going to be going over finding the surface area and volume of a cone. So just like yesterday, we're going to be heavy on Desmos, but I will show you the longhand way per se, or at least how to set it up, and then you can just type it in the calculator. So when we look at a cone, the three big pieces of information that they're going to give us are our radius, which you can see here in yellow. Oh, that's red. I'm on yellow. There we go. Here in yellow. That's going to be our radius. Remember, our radius is going to be half the diameter of this circle base. All right, then we're going to have the height, which you can see here in green. That's going to be very similar to the height from the square base pyramid, whereas it's going to start at the point, come down to the middle of the base inside. And when it's inside, that means that you're going to use it for volume. And it's going to make a right angle with the actual base. And then last, we have our slant, which is going to be this outside line of our cone. And that's going to come from the tip down to the base. A little correlation here, you can see that the height, the radius, and the slant all together create a right triangle. So you won't have to deal with this on this particular test, but maybe down the road in another grade, you might see a cone and they don't give you a piece of information, but you'll be able to find out all of the information. Say they give you the height and the radius, you can find the length. Or if they give you the length and the radius, you can find the height and vice versa. So, all right, so let's just start off with number one. I'm going to show you this Desmos trick. All right, so for the sake of time, I already have our formula in for volume, so you guys can pause here. I also have all of this screenshotted in a document that's in your test day folder. Remember, you have a test on Friday, December 4th. So all of this info is going to be in your folder. So what I need to do is I need to look for my radius and my height. So when I look for my radius, look for my radius R, and I need to look for my height H. So when I look for my radius, I think looking for your radius is going to be easiest. I mean, yes, it's not, none of this stuff's any more challenging than anything else. But I say you look for your radius, just kind of like when we were doing the square base pyramids, we look for our sides first. So let's just mess with the base of this shape, right? So we know that our radius starts in the middle, comes all the way to the side. So in this problem, they give us our radius. We don't have to do any other math. So our radius is going to be 8. There's only one other number, which is our height. Remember, that starts from the point and goes all the way down inside the cone to the center. And that's going to be 15. Just like yesterday, I should point this out right away. We're looking for volume. Right, so we're going to want to make sure we're using our volume equation. Also, when you're looking for volume, you notice that the height is inside the cone because volume is if you're filling the cone up with something, water, sand, air, whatever. All right, from here, all we have to do is put in our 8 and put in our 15. And you'll see that it gives us our answer, which is 1004.8. Don't forget it's meters and it's cubed. Do not forget cube. That's also a big factor or a big key. So I had to turn the light on. Big key to point out when we get to word problems, because if it says like what's the cubic meters of this cone, you know you're looking for volume, right? Because it says cubic. All right. So if you want to do this longhand, we know that volume is going to equal 1/3. Remember, our pi is just going to be 3.14. When we know our radius is 8, we're going to square that, and our height is 15. Now, you can just string this along in Desmos, and it'll give you an answer. If you do just a little bit of freehand math, I know that 1/3 and 15 is going to give me 5. I know that 8 squared is 64, and then I have my pi. All right, from here, you're just multiplying these three numbers, and I promise you, if you put it in the calculator, you'll get the same answer. All right, going on to surface area now. Well, you see that they give us 3 pieces of information. But when you look in our surface area equation in Desmos, right, again, you can screenshot this, pause, whatever you got to do to use this. Make sure you have it written out correctly in Desmos. We know that we're going to be looking for our radius, but we're also going to be looking out for our slant. All right, an L, SL slant, L slant. Some people are calling it the length. I'm cool with that. Whatever works for y'all to make sure you get the right answer. All right, so let's talk about our radius. Well, our radius is from the center of the base, which is a circle, out to one of the sides. Well, what they give us here is this whole line, right? They give us from one side of the circle base, sorry, all the way to the other. But we don't need all of that. You can see where I drew in black, we only need half of that. So what we're going to do is we're going to divide, because what they gave us was the diameter. Well, the formula or the way to find your radius when they give you a diameter is just to cut it in half. And when you cut something in half, you divide by 2. So we're going to have 28 divided by 2. And that's going to equal 14. All right, now we have to look for our slant. Well, again, I probably should have pointed this out first. We're looking for surface area. And when we're looking for surface area, we're looking for the outside, like if we were going to paint this or paper mache it or cover it in paper or something, right? We're dealing with the outside of this figure. Well, the height, which is here, which I'm graciously crossing out because we will not use it, goes inside the figure. So we're not going to use that when we're doing the surface area of a cone. What we are going to do is start at the point, and we're going to go down this side. And you'll see that this side, that this line that we drew is actually like a slanted line, right? So that means our slant is going to be this 50. All right, and just to drive this home, we know that we're only taking half of this diameter to give us our radius. So that's why it's 14. Whoops. L. So just plug it in. Now, like, you don't even have to put 14 in. You can just put 28 over 2. It'll give you 14. It'll solve it for you. And it's going to plug 28.2 everywhere you have an R above it. And then for the length or the slant, we type in our 50. And bam, you'll see that our answer is 2,813.44. Remember, that's going to be meters squared, because it's an area. Now, if you wanted to do this the long way, we would have area equals, remember our pi is 3.14. We know that our radius is going to be 14. We're going to square that. And then we're going to add 3.14 times our radius, which is 14, times our slant, which is 50. And I'll do this on a calculator. So on one side, I'm going to get 615.44. And on the other side, I get 2,198. And I can assure you that when you add these together, you will get 2,813.44 meters squared. Just to note out, if you did do it the longhand way, you could just throw this in Desmos, leave the A off, or I guess you could probably put the A in there either. And remember, I use that A to remind us that we're using surface area. I can't put two variables next to each other, so it'll give us the angry triangle of nonsense. All right, so the rest of this is just pretty quick. Make sure you clear out your Desmos, but do not delete these formulas. Do not delete, because we're going to use them for the next 4 questions. All right, so we are looking for the volume of a figure. We know we're looking for volume, we're looking for radius, and we're looking for our height. Well, when we're looking for radius, we go from the middle of our circle out to one of the sides, and you can see that they give us the entire diameter, excuse me. And when we do that, we need to divide by 2, which would be 6.5. Our height starts at the point, goes all the way down inside to the middle, which would be 32. Remember, when we're doing volume, we're looking for the inside area, or the inside volume of this figure. So that's why our height is inside. And then all we have to do is type in our answer, or our information that we know. So radius is 13 divided by 2, height is 32. And you can see that our answer would be A, 1,415 inches cubed. Remember to delete, but do not get rid of everything. Now we're gonna look for surface area. Again, they give us 3 pieces of information. I would like to note that right away we can get rid of this height. We do not need this height at all. So we're gonna look for our radius. We're gonna look for our slant or our length, as some of you like to call it. Instead, I don't care what you call it as long as you get it right. So our radius here, they give us the actual radius, which is nice, right? They only give us half. There's no perforated line continuing here. So we know our radius right away is 10. We know our slant is going to start at the point. Now notice this cone is flipped upside down, but this circle right here is still considered the base. And we just draw our slant line all the way until it hits the circle base. And we'll see that 24 is our length. And again, all we have to do is plug this in, bam. 24 for our slant, bam. You can see our answer is 1,067.6 centimeters squared. And then don't forget to clear them out, but do not get rid of your Desmos formulas just yet. All right, so now we need to find the volume. Looking for volume of the following figure. So let me highlight a couple of things here. I actually think these are easier because they give it to you pretty straightforward. So you're purchasing an ice cream cone, whatever. The cones have a radius of 3 and a height of 6. How much ice cream can you put into the cone? Well, we know that we're looking for our radius and we are looking for our height. So it gives us right here, radius 3, height 6. Plug it in. Get our 3, our 6, and you'll see that our answer is 56.2 centimeters cubed. Another thing to note here is, let's say it didn't say volume here. You should be able to tell that you're looking for a volume because it says how much ice cream can you put into the cone. Not how much ice cream can you smear all over the outside of it, because that'd be kind of gross. All right, and last, we are looking for our surface area. So again, with the old highlighter, we're going to see that we have Cindy wants to cover up the cone-shaped bottle with fabric. The bottle has a radius, nice, of 1 inch, a height, nice, of 2.5 inches, and a slant of 3.5 inches. How much fabric does Cindy need? Well, we know when we're looking for surface area, we're looking for our radius. Oops, trying to be consistent. Radius. And our slant, or our length, our L. Well, they give us the radius, so that's 1, which is great. Everybody loves to multiply by 1 because it just doesn't do anything. And we're looking for our slant, which is 3.5. So you guys have to read. First of all, you know it's surface area. So we know we're looking for radius and slant. It gives us radius and slant, but it also gives us height. But we know we don't need to use that for surface area. And that's how they'll get you. Because they'll give you the answer. They'll also give you the answer of the volume. And if you don't do it right, use the volume formula, you'll get the right answer for volume, wrong answer for the question. So again, we just put it in our 1, plug in our 3.5, and you'll see that the answer is in fact B. One other thing to kind of show you guys here, if we did not have this surface area statement, you should be able to tell that when Cindy wants to cover up the cone-shaped bottle with fabric, right? So that means that she has her cone. I'm not an artistic person, but she has her cone, and she wants to cover the outside of it, right? She doesn't want to fill it up with anything. She wants to wrap it up in fabric. So other than that, that's pretty much it for today. You guys did really, really well. Don't forget we have a test on Friday. Good luck. If you have any questions, email me, hit me up on Schoology, whatever. Have a good one.